This is what we're about to talk about. Okay, so let me do it out of the context of that problem so you guys can still have that for homework. So we talked about this before. So what if I know the sum n equals 1 to infinity of an is L? Yes? You with me? So what if I wanted to know what this was? What's it missing? Like this one, if I broke this out, what would it be? If I wrote all the terms, yes? You could do it. I didn't tell you anything, so it's going to be very minimal what you have to do. So what's the first term of this series?
A1.
A1 plus
A2.
A2 plus
A3.
A3 plus blah, 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 blah equals L, yes? Where does this one start? A3. So what is this one missing? So this would be L. This is not equal to L, is it? It's equal to L minus A1 minus A2. So I can have a situation where I just need to take the first couple terms out. Nothing changes inside. So a better way to show this is, let's say I have this. Yes? How can I make it this? Did I change the function? Nope. What has changed? The index. So I didn't change the function. I didn't change the function. So how could I do this? And I kind of gave it away with the blank space, yes? What do I have to figure out to put in that blank space? It's related to the one we just did. Yes, the first term, right? What's the first term of that series?
105.
So this will be 1/5 plus the rest. Is that cool? Okay, so there's the idea, and I always choose the weirdest word to say this, but the idea of plucking out the first so many terms for some reason. There could be a reason that I need to take a few terms out of the way, yes? In fact, we have talked about this. If I have a theorem that needs my function to be increasing or something, and the first few aren't increasing, I can just pull them out. So then the resultant series does that. Does that make sense? We talked about that before. I just need it to eventually start doing this thing. Because I can take the first finite number of terms out, and then the rest of it does what it has to do. It meets the requirements. We talked about that last time. So that could be a reason why I would want to do this. The other major thing I could do to kind of like modify a series is this. What you got, Jeff? It doesn't matter, Jeff. Okay. What if I want to make this start at 1? I'm not taking terms out. I just want to make it start at 1 instead of start at 2. Do you guys see how fundamentally the inside has to change now? I don't want my series to be different. I just want to call everything by a different name. So okay. What did you get on top what's the first term from this series? What's on top of the first term?
4.
4, yes? You guys with me? So whatever I write here, it better give me a 4 on top when I put a 1 in, yes? Okay, maybe. So, I am making my n go down by 1. To compensate for that, what do I do with my n's inside here? Increase them, yes. So this is a very algebraic idea. This is kind of like the idea of a y-intercept. If I want to make my line go up, I add 1. This kind of idea of if I want to take a step back, I better increase what I'm doing to the end when I plug it in. To overcome my n starting at 1 now, I need my functions to add 1 to it first. so that makes it stay the same. Does that make sense? Maybe? Okay. It's nothing more than that. I'm feeding this poor little dude one less than it used to be. So what's it need to do for itself? It needs to add 1 onto n first so that it stays the same. So if the function responds to this by saying, all right, I'm going to add 1 to this, I'm going to add 1 to this, now it's going to have all the same outputs, yes? I did not change the series. I just made it start at 1. So there's 2 distinct manipulations. One is literally just taking the first so many terms out. And how many you take out is what n is going to be at the end, right? So it determines where you're going to start in the series. The other one is more subtle. You're not taking terms out, you're just rewriting how it's defined. And I think I told you guys, because later this semester we want to add series together. So the idea of like terms is going to come into play. You can't add anything mathematically unless they're like terms. Okay. And just in case you weren't here for what prompted this discussion, it was that problem we started looking at last time. 11.3, right, Sarah?
Yeah.
Because of course I closed the book. Every day? This one, where you got these little adjustments happening, yes? Okay.
So
This one's nowhere near as bad as you think. Is that one you're worried about now? So this
no, I think I
one,
understood that one where like you can
Alright.
just pull out a
Sure.
1/4 or whatever. Sorry.
this guy has got a little bit of this and a little bit of that. A little bit of what we had to do here, but not until you first. So how do I make this look like that? How do I make this look like that? Take away 1. If I take 1 away here, how do I compensate for that? I make the n start at 4. Again, it's the idea of compensation. Do you guys understand? I need you to understand. So here, this one, I took 1 away from it, so it overcame it by adding 1. I'm like, I'm going to feed you 1 less, so then it added 1 on itself. So it's like, I'm still cool. Okay. This one, I want this to go down by 1, so I better make this go up by 1. So it actually compensates. So it ends up being the same thing. What do you get on the bottom when you put a 3 in? Right now. What do you get when you put a 3 in? 16. Okay, good. 16 on the bottom. If I take the plus 1 away, I now have to put 4 in to get a 16 on the bottom. So if you ever have to do this manipulation of changing the index or taking it, you can always just check. Make sure you still get the same first term, right? You guys kind of with me? It's not that big of a deal. It really isn't. Okay. Because the way we define functions is sort of arbitrary. In this case, it depends on where I start. And if I change where I start, then the way my function is defined changes accordingly. Yes? Maybe. Okay, so that's one little tiny problem. This idea, though, I like that they're planting the seeds a little early. Later this semester, it's going to be a big part of what we have to be able to do.
So how would you do the whole like limit thing for everything? Because you want it to be simple.
You don't have to do any work after that. Once you make this look like 1 over n squared, you might have to do what we did in the first one if the n's isn't 1, yes?
Yeah.
And pull a few terms off, yes? Once the inside is 1 over n squared, it's basically going to be this minus something maybe if you're starting later in the sequence, right?
Oh.
Yes,
okay.
the same thing we did on the first one. Yeah. So the second one has 2 adjustments you have to make. Okay, so let me catch up.
Second one
Who,
has 2 adjustments? Oh yeah.
the one we were just talking about.
Yeah.
Who didn't get their quiz back? that everybody? Oh, oh, boys. Alright, that's everybody. Okay. And then the stats are up here. Overall, I mean, look at this thing. That's pretty good. 81.3% pass rate. Decent little distribution. You make corrections like always. Yep. When is our next test?
The Thursday we come back.
Yeah! Alright, so I'm not quite evil enough to put it on the Tuesday, but I'm just evil enough to put it on that Thursday, so. Let me go ahead and give you the practice test in case I start talking about something and I really bore the shit out of you. You can look at the practice test.
And what sections is that going to cover up?
Through 11.5.
Okay.
11.1 through 11.5.
We did 11.
Yes.
I watched a little bit of video.
This
Maybe we'll
is,
get some of it.
Yeah, yeah. Pretty mature thing. And all right, so maybe don't look at that too much. You can put that away, unless I'm really boring, and then you can. How boring do I have to be for you to go? It's better for me to look at this practice test. Sounds like a challenge. Let me see if I can do it. So anything else before I jump back into where we left off? Huh? Oh, I'm sorry. Somebody said for interval test, right? So let's do that, and then you got a question for homework. So, I mean, okay. Do you guys understand? For example, if I want you to use interval test, I could give you this. Can you guys look ahead to see what this would require from you? So the instructions would say, use the interval test to check this for convergence or divergence, yes? What would the associated interval be? Oh, and real quick, I'm really loose with this, and it's just too bad for everybody. Do you guys remember the requirements for the interval test? Your function has to be
It's
continuous,
supposed to be continuous and are also supposed to be
positive,
Positive.
good,
and
decreasing, kick ass. I'm not gonna be too picky about, I mean, if I really was picky and it said show that this meets the requirements, the hardest one to show, do you all agree that's very much positive? That's so positive, it's crazy. How would you show it's decreasing?
Plug in.
Take its derivative, yes. You guys got it with me? So that is definitely decreasing, so who cares? What does the associated integral look like? What's the limits on the integers? This is one thing you guys forgot on that integral test. 1 to infinity, so I'm gonna have to change that in a minute. I'm just gonna go straight and then we'll change it. What happens inside? Good. And then I gotta bring the limit into play. And then it's not a chapter 11 problem anymore, yes? It's everybody's favorite chapter, chapter 7. And what method would I use for this? Could I use USUB? No. Can somebody tell me if the top was what power? You could do USUB. First power or third power?
Oh,
U equals x squared crap, so du is crap x. So if I had an x up top, it's good, but if I had an x cubed up top, that means I would have an x and an x squared. And then I could solve u equals x equals 4 for x squared. You guys kind of with me? That little adjustment you can make with u sub. Okay. So that was a little more advanced of a question. That's like a bonus question I might ask, like, what would you put on top in order for this method to work, for this method to work? Yes? Now, I mean, my point here is, any problem they give you where they say use the interval test, you would, it could be any interval. Anything from chapter 7, anything from calculus. Yes? Yeah.
Did you start the video?
It is.
Okay.
Let's go.
I just wanted to make sure because it wasn't over here.
I know. I'm doing this. I don't know if you guys, if anyone's watched the videos, I think it's a little better because there's not as much glare. Also, you don't have to see me walking around, so that's an extra bonus. Okay. Is that all right? I mean, we could do this if you wanted to, but I don't know. So the point is, the interval test just means write the associated integration. It's a built-in improper interval, yes, because we're going to have an infinite series. And then you just attack it with whatever. Normally, I'm going to give you something that's not too insane. I'm not going to suddenly make you redo all of chapter 7 in these problems. You guys kind of with me? I don't think they give you the intervals you have to do. I don't think they're too exotic. I think they're normally like U sub or something. You guys kind of with me? Has anyone done the 11.3 homework yet? Would you agree with me?
Yeah.
Yeah. There you go. Is that okay? I mean, so then you just have to know how to integrate that. So that would be a trig sub, and what would you let x equal?
Tangent.
Yes, 2 tangent. 2 for the 4, tangent because it's squared plus number. That's tangent squared plus 1. That's the form it's in, yes? Okay. So don't, again, it shouldn't happen maybe once or twice, maybe in the homework, I can't remember. And I'm probably not going to give you one that's too crazy, but yes, I'm going to assume you know your chapter 7 because we did it. So if I wanted to, I could put this in the test. Is that all right? And the whole idea, what's the whole idea? If I do the limit, what am I looking for? Yeah, what 2 things could happen? It could either go to infinity, in which case, what does a series do? Yes. Or it could go to not infinity, which means a finite number, yes? Any finite number. I don't give the first shit what that number is because it does not directly relate to the actual sum. Okay. If only it was that easy. But it isn't. So, I think I told you this before. Most of the series we're going to work with, the most we could say is they converge. If we're lucky, it's geometric or something where I actually have a formula for what it converges to. Most of the time, we're not going to have a clue what it converges to. In fact, if you look at that proof I put up, sum of 1 over n squared, does that sound hard? Sum of 1 over n squared, does that sound hard? No, but it's silly hard. It is so difficult. And just to make sure you understand, it's not something you're going to have to do. Yes? Mm-hmm. I mean, it took this Euler dude a lot of time to figure it out. And what he did was really cool. So anyway, we'll see if you guys take a look. All right, anything else from homework stuff? Or you said number 30?
38
38, where?
in 11.3.
Okay.
It's the last question.
It's the final question. Oh, okay. So to get S10, what are you going to have to figure out? What is S10?
A1.
It's A1 plus A2 plus A3 up to A10, yes? The sum of the first 10 terms. I like it. And then it says use 3. Now what does this mean? What do you think that means? I mean, if you read this, what do you think? Use 3.
The number 3?
So it references a process they talk about in the, here, is that it? I can't see. That's 1. That's 2, there's 3. It seems, see how it says use 3?
Yeah.
No, okay. And that's the 3 it's talking about right there. So use 3 with n equals 10, yeah. Huh?
I said that doesn't look too pretty.
Poor little thing, look at it. Poor little, whatever, Sarah. So mean. So we actually talked about this. This is the error, the remainder function, the error function. So you've got a nice example to go by. Yep. So it wants you to calculate S10. Is S10 the actual thing this adds up to be?
No.
Obviously not, because then you would add S11, S12. But do you think, does this decrease really fast? 1 over n to the 4th? Yeah. When I plug a 2 in, it's 1/16 of it. When I plug a 3 in, that's 1 over 81. That thing is decreasing quick. So S10 should actually be a decent estimate, because S11 would be 1 over 11 to the 4th. Do you understand? Is that a tiny number? Come on, you guys can do it. 1 divided by 11 to the 4th.
Yes.
11 to the 4th is big as shit. It's pretty big, yes?
But 1 over it.
1 over it, it's pretty damn small. Do you understand then, if I stop at the 10th term, that should be close to the right answer for the whole thing, because the next terms are getting really stupid small. Okay? So real quick, just because if you guys would have just reacted a little bit better, I would have not done this, but here we go. So I got, let's do this. I'm gonna leave that one for you. What's A1? 1, what's A2? Good, what's A3? What's A4? I don't know. Let's see. 64, 256. So that is that 1,000? No, 1,024. What do you think? $256. Yeah, it's 1,024. I think. Yes. Thank you. Now, real quick, 1 over 1,024 is roughly 0.001, yes? It's roughly 1,000th. Are you guys with me? And then the next one is freaking 1 over, where am I at? 5 to the 5th power. And I definitely don't know what shit that is. 625 times 5 is 3,125, I believe. Which is roughly 0.0003 something. Do you guys, all right. Do you guys see how, I need you to see this. If I add up through A5, I've got like the first 3 decimal places at least locked in. Because everything after that is going to be adding stuff in the next decimal places over. You guys see what I'm saying? So if you just are working on an issue and you just need to be correct to the 3rd decimal place, you don't have to go very far in the series because the numbers are getting so small so fast. Does that make any sense? Thank you. So a lot of this is, you can look at it one of 2 ways. Well, here's the main one. I've got a function I'm working with. It's really, really gross. It's so gross I can't even write a function for it. It's just given a series. Yes, but I don't need the exact answer, thank God, because nobody has time to go to infinity. And Euler didn't do this one for me. But I could just use so many terms of it and be really close to the right answer. Okay. So this is all about tolerance. How far you go out in the series is dependent on how important it is to be so correct, so accurate. It may you ever machine anything? Anybody ever machine anything? Anybody ever works? Yes? What have you done? What have you done? Sorry.
Kind of just, I've done a bunch of 3D printing.
Okay.
and, like,
This is perfect. Have you ever done 3D printing where something else has to fit into something else? You have a certain error tolerance, does it make sense? So when you create something and you have to have something else fit into something else, there's a certain tolerance in which it would work. If it's too small, it's not gonna go in. If it's too big, it's just gonna come right back out. But there's a bit of a wiggle room where you have some tolerance. So this is what that means. If this is too small, my screw can't get in. If it's too big, it's gonna come right back out. Yes? But in the middle, there's a range of acceptable values. So this idea of how accurate do I need to be is in mathematics, but it immediately carries over into engineering, into any kind of design work. Okay. All right. I'm sorry. That's it. I'm sorry. Okay. Get away. Okay. Anything else from homework stuff or quiz or anything? Okay. We have, where'd it go? This. Does anyone need this handout? Does everybody have this handout? So we did this a while back. Last time we talked about alternating series, yes? Just to kind of look at these alternating series again. Let me know if you need one. You need one? Yep. Okay. And this is not so much just alternating series, but can you guys look at number 2? I'm pretty sure we didn't look at that last time.
We did.
We did?
Yeah. Really? Yeah.
Oh my God.
We looked at, I think, all of them.
We did?
last time.
Okay, that's actually cool. I
yeah.
thought we didn't. Well, but real quick, do you remember number 2?
Yeah.
What was number 2's problem? It's not going to make it, is it?
That it was like, we couldn't tell.
Well, what's the limit? So real quick, guys. What part of number 2, the series in number 2, what part of that is an? What's an?
N over
Good. N over 2n minus 1. You take the -1 dependence over to the side. The -1 piece is what told you it's an alternating series. Then the test says, okay, great, put that on the side. It told you to do me, and then you have to show it's decreasing. So what did I tell you guys? Even though I listed it that way, and I really should change it for the future, but I should do number 2 first. What is number 2 also known as? Checking to see if that's true. Test for divergence. So what is the limit for number 2?
1/2.
1/2. So that dies right off the bat, yes? That's why you try that first. Almost no matter what. Unless you have a geometric, which is pretty easy, right? Or a p-series. You with me? What's a p-series?
That's where P, if.
1 over n to the p. And what's got to be true about p?
Is it PS to be
Greater than 1. And how do you, don't just memorize it, why does it make sense? Because if I want a series to converge, I want every element to get really quick? Really small. So if I have a bigger power on my denominator, the whole thing's getting small quick. So of course p greater than 1 jives with that, yes? And the word is jibe and not jive. Okay. So alternating series, students are always, understandably, the hardest part about any math class is, when do I do this? Yes? You guys, you've done a lot of math. You're in calculus too. You know exactly what I'm talking about. I understand how to do this. Just when do I do it? And I'm like, good luck. No, but for alternating series, that's in your face. You see the -1 dependence directly. I'm going to do alternating series. Of course I am. Do you guys remember how to show number 1? There's 2 ways. One of them doesn't work that often.
Oh, where it's like the.
Like if I wanted to do this and show number 1, I'd have to show an plus 1 is less than or equal to an.
Mhm.
So then I have to
Like
write
cross multiply and-
an plus 1 and try to see if I can show that it's less than or equal to this. And very often that's not
Mhm.
easy. Now I did tell you guys, let me see. Let me show you this. So if I'm working with this, I'm pretty sure we did this last time, but just to remind you guys. So I'm working with this, and I'm going to show that the next term is less than or equal to the term before. This is one reason why it wants to have positive terms. So I want to show that this is less than or equal to this. So I'll put a little question mark there. Does anyone remember? In fact, I think I did it with this. And this is what I showed you. It doesn't really work well, does it? So you try to cross multiply. So if you bring this guy up here and this guy up here, then if this chunk is smaller than that chunk, this has got to be true. Yes? Okay. And in this case, it's not the easiest thing in the world to see. So what's the other way to kind of show that this is decreasing?
Take the derivative.
Take it over. Yes. And we did this, we did L'Hopital's rule, yes. So sort of like your question about the integral test. If I have to take a limit anytime, L'Hopital's can come in anytime it wants to. L'Hopital's is not a step for series, L'Hopital is a step for limits. And I have to take a limit for series. Okay. And then we did direct comparison. So for example, everybody had a problem on the quiz that looked something like, oh my God, I don't have a clue what it looked like. There we go. Where's a good example? Yeah. Where's that one at? Yeah, there it is, okay. Looks something like this. Yeah? You guys concur? That was number 4. Yeah, the last one. So that one I had you guys do integral test. And do you guys remember what I said about integral test? I want to remind you. Integral test is why P-series exists. And P-series kick ass. I want to remind you of that because once we learn direct comparison, and we have, and limit comparison, which we're going to, integral test almost never has to be used directly. Well, there will be times when it will need to be used, but they're going to be far and few between. Does anyone remember? Now, real quick. On the side here, I'm going to strip away all the shit that's not n. You guys with me? I'm just doing that. I'm sorry. You should say no, Jeff, because you're hiding. Okay. Because, okay. So how does direct comparison work? What do I need to know before I can start the process? Because what were the two things that could happen? I either need to find a floor, and then it goes to infinity, meaning I have to have an idea that the series diverges. Or I need a ceiling, so I have to have an idea that it converges. So I have to go into this having a good guess. Does that make sense? Direct comparison allows me to get rid of the 1. But I have to do it in a very controlled way. Yes? I can't just erase it. I have to actually show that it does what it's supposed to do, or else I'm not really showing the logic. But to get an idea for it, I can just do that kind of shit on the side. What is n squared to the 5th power?
10.
Yeah, n to the 10th. And what's the square root of n to the 10th? Because it cuts it in half. And what's n over n to the 5th? And what does that do? What's this series do? No, stop saying goes to 0.
Wait,
What's the series do? Converges. Series definitely doesn't go to 0 because it's made of nothing but positive terms. The sequence goes to 0, which means the series has a chance to converge. Why do you guys know it does converge? Because it's just a little p-series, yes? Okay. All that shit we just did is side work. You can't base your answer on what you just did. That's just like, okay, do I get a ceiling or do I get a floor? So which one do we want to get for this stuff? Which one do I want to get, a ceiling or a floor?
ceiling.
Ceiling, because we know really good. I know this has got to converge. I just have to mathematically show that now, because the shit I just did doesn't mean anything. It's not good enough. It's good to get a feel for it. It's not good enough to prove a damn thing. That happens a lot in mathematics. So if you ever run across a mathematical paper in a journal, there's a lot of shit that happened on the side. Got a feel for something, and then they kind of went back and they proved it with structure. Okay. So I want to start here, and I want to work my way until it becomes something that is, I want a ceiling, right? So I want this to be less than 1 over n to the 4th. If my series is less than that, then it will converge, because it can't go to infinity. It's got this bigger series that converges. Does everybody really get that idea? If I have something that's always bigger than me and it converges, I can't go to infinity. I'm like, I can't. Okay. So now I know what I'm trying to do. Every step I take, I'm trying to make that bigger. That's what would make the inequality go. Whatever I write here, I want a less than symbol in it, which means where I started is less than where I go. So how do I make this bigger? This one's not that bad, because there are 2 things that could happen, yes? How do I make that bigger? So you are allowed to do shit like erase the 1. Or replace the 1 with something that's like terms with something. Does erasing the 1 accomplish what we need? If I erase the 1, is the resultant function bigger? You could do it. You're better than this. Does it make the bottom smaller if I erase the plus 1?
Yes.
Does everybody see that? You see that? Right now it's n squared plus 1. If I just say n squared, isn't that smaller? Not sure what's happening. People are still. So, which one is bigger? Which one is bigger? N squared or n squared plus 1?
N squared plus 1.
Yes, yes, yes. That's bigger, yes? So if I make the bottom smaller, then I made the whole thing bigger, yes? You guys see that? So your first step is, what's my gut telling me? Kind of erase some shit just kind of haphazardly and get a feel for it. Looks like it wants to be 1 over n to the 4. Well, that converges. So I want my inequality symbol to go this way. Meaning every step I take, I have to make it bigger. Now to be honest, we're there. To do this stuff we did earlier a different way, what's the square root of n squared? Square root of n squared? N to the 5th power. So that's equal to this. And what is that equal to? 3 over n to the 4th, yes? So this, sorry, this is trying to be an equal sign now. This is bigger than this, yes? And what does this guy do? Converges. So what does our function do? Or what does our series do? Converges. Shabbat. If I make a series, or an that is bigger than the one I'm talking about, and it converges, so do I. If I make a series that is smaller than the one I'm looking at, and it diverges, so do I. Maybe? Okay, so I don't remember, I don't think we got to the point where we actually looked at any of these, did we?
No.
Alright,
So if it converges, then we want the stuff that we're doing to be less than,
we want, if it converges, I want the inequality symbol to go this way. Meaning the new thing I'm making, it has to be bigger.
yes.
And then vice versa for a floor, for divergent. So, can you guys get the idea for this? I mean, this one, it's on one level, you're going to find it kind of silly, but I want you to get used to this test. 1 over n cubed, what does that do? Converge. So if I add something to the bottom of it, doesn't it make the bottom bigger? Doesn't it make the whole thing smaller? So what do you guys think that does? It should converge. And even so, all right. So which way do I want my inequality to go?
Towards what you're trying to get it to.
So I want to make a ceiling, yes? Because it converges, thankfully those have the same first letter. If it diverges, I want down, a floor. So which direction do I want my inequality symbol to go? I want the thing I'm about to write over here. I want it to be a ceiling for me, so I need it to be like that, yes? And then I started off nice. How do I make that bigger than what it currently is? And this is the tricky part for you guys. You are not used to being able to take what I've given you and just take part of it away. Why is it fine? I just need it to follow an inequality chain. And 3 is less than 87 billion. Yes? So if I give you the number 3 and you say, well, that's less than 87 billion, you are correct. You have not changed what I gave you. You made an actual correct statement. It's less than that. Leave me alone. I'm trying to figure out what might be your stumbling block here. And normally for students, it's the fact that you're allowed to just change what I gave you. You're not changing it. You're comparing it. So if I compare that to, yeah, if I did take the root n away, that makes the bottom smaller, because right?
Which makes the whole thing
The bottom has less stuff, so it's smaller, which makes the whole thing bigger. So that means I want to do that. And then I'm there. I made a ceiling. My ceiling does what?
It
Converges. Therefore,
So
my
that
series also converges. It can't go to infinity because it's got a limit there. It can't go past the other two. All right, let's see how far you can go with number 2. People in the streets. People in the street. Thanks. Okay. Does everybody not get their quiz back yet? So now you have to worry about something on top, something above. Can you just see it? Just to make sure everybody's on the right track? What is that trying to be? Is everybody cool with the way I say that? It's not a very technical way to speak, and apparently I don't care. I think when you're first learning mathematics, it's cool to be a little more loose with your speech. If you were going to write an article for the Mathematical Journal of America, you're not going to go, yeah, it wants to be. No, you're going to be very technical in your writing, yes? But for understanding a concept, we can just talk a little looser. That's trying to be 1 over n. Therefore, I'm looking for a ceiling or a floor?
A floor
Floor,
because it
because I want it to push me to be divergent, yes? So I want my inequality to go the other way, okay? Now, just want to make sure everybody's on the right track. Try to do like we did on the first one. That was much easier. So I gave you the harder problem, son. You're a great guy. So everything I do you see how I want a 4? So I know my inequality's gotta go that way, so what I'm about to write is smaller. So it could be a floor, yes? Because that controls everything you think of next. Look at the top. Start with the top. To make a fraction smaller, I want to make the top smaller. Yep. The bottom is the opposite, yes. Okay. You guys with me? 7/8 is definitely smaller than 9/8. Okay. What's the easiest way to make the top smaller? We remove the 1. So the first step is easy. Now we want to keep the party going. Why can't, or why just get away? If I remove the 2, does it do what I want it to? If I remove the 2, it makes the bottom smaller, would make the whole thing
bigger.
Shit, it goes against what I know I need to happen. Yes? You guys see what I'm saying? You have internal checks and balances as you do stuff. So what's the other? There's only 2 things that could happen. Either you can erase the damn thing, or you can replace the damn thing, right? And what do I want to replace it with? So for example, if I rewrote it as n cubed over n to the 4th plus 2n, do y'all agree that very quickly that bottom is bigger? Because n goes 1, 2, 3, 4, 5, yes? It's going to be bigger, which would make the whole thing smaller. But is it going to get me to a place where I can rewrite this as some kind of 1 over n? No. What do I wish was on the bottom? What sucks about the bottom? I wish the bottom was just 1 term, yes? So why does it, so I mean, erasing shit, oh, that's the best. There, I can make 1 term if you would just let me erase the 2, Jeff, but it doesn't logically follow. So the other thing I could do is make it like terms. So I'm not gonna make it 2n, I'm gonna make it 2n to the 4th. Then it's like, then it becomes, then I can put them together. Then I got 1 stupid term and the damn thing can reduce, right? So, if I replace 2 with 2n to the 4th, you all agree that this is at least that. If n is 1, those are equal, yes? Yes? Anything else, the second dude is smaller. Because I'm dividing by more, aren't I? If n is 1, these are both 2. If n is 2, that's 2, and that's 30 frickin' 2. That makes that very big, it makes this much smaller, yes? And now what can I do at the bottom?
Put it together.
Put it together. You can do it, Jeff. There you go, buddy. And then this becomes 1 over 3n. Constants don't bother us. 1/3 of something that goes to infinity still goes to infinity, correct? Okay. So all I care about is the n-dependent part. That is 1 over n. What does that do? Diverges. Since that's smaller than ours has to diverge. Do you guys get the idea? Okay. So some of you guys look like you died a few years ago. You're just staring at me. Okay. So this diverges, therefore ours diverges also. Bam. Okay. Maybe. This is tricky. I understand that. You'll get it. So what about number 3? I like number 3.
Some kind of geometric.
Hey! I'm sorry, I'll come. It is not geometric, but it wants to be geometric, yes? Because what's the immediate tell?
Is that it's not n minus
Well,
1
n is in the
in the denominator. No, in the power.
power, right? Something to the n power makes me think geometric automatically. N to a power makes me think p series. So the last two we did were p series because they were fundamentally like polynomial in n. Yes. This one is exponential in n. I'm thinking geometric. I want to compare it to geometric. And what would that corresponding, if you just erase the 3, what would that corresponding geometric series do? And we converge. So this one, I end up with a nice easy one. You guys do it. Oh wait, it's a nice, it's a nice one. So that converges. We feel really confident about that. So what do I want to find?
Something
A
that's
floor or a
smaller.
ceiling? A ceiling. So that I keep my series from going to infinity. Okay. Get some more room here. So you start with what I got. Which way do I want the inequality to go?
You want the thing that you're making to be bigger.
Yes, I want it to be a ceiling, so I want it to be above mine. Does that make sense? So that's a good way. The ceiling would be above, so whatever I put here, I want it to be bigger than me. Floor would be below, so then it would be the other way. Okay. So the first thing you do is just make sure, does it work if I just take this away? Does it make it bigger overall? Yes, because it makes the bottom smaller, so it makes the whole thing bigger. That's why I told you guys it was an easy one. This converges. Now, real quick, if this was on a quiz or a test, don't just say converges, you'd actually have to say why. Converges because everything I wrote R is 1/5, which is less than 1, geometric. Bam, yes? Okay, if it's news to you that you must show me work, you just started paying attention. Okay. Does that make more sense? Does it make sense? Does that make some sense? Okay, again, I don't want to play poker with most of you guys. Okay, so last thing. Before the last thing that's going to be on this test is what's called the limit comparison test. And before we get into the actual test, I want to ask you a seemingly unrelated question. Let's say that I know that this converges, yes? I know this converges. Good for me. What do you think about this guy? Does that converge or diverge? Does everybody understand what that is? Let me look here. 41. It's a number. Yes, 41. So the sum of 41 AN. Does that converge or diverge? So if sum of AN converges, what does that mean? If that series, that first series converges, what does that mean? Okay, let's be very careful how we speak.
Series.
I love it though. It's a good point. Real quick.
Converges.
No. Okay. All right. This does mean that the limit as n goes to infinity of the sequence is what? Yes. So if it converges, the limit must be 0. It does not work the other way around. Yes? If it rains, I'll bring my umbrella. If I bring my umbrella, that's not going to make it rain. So logically, if P then Q doesn't work the other way around, always, only sometimes. You guys are all with me. So if I know a series converges, that means the limit of the sequence that's in it goes to 0. Now, more directly, if it converges, what does that mean? Just straight up. Say again? Yes. It's equal to a finite number, correct? So if the sum of n, let's just say it is 20, whatever that series is, yes? What's this got to do? Huh? It would just be 41 times 20, yes? Really quick, watch this, watch this. Can you guys help me out? What's the first term in this series? Let me be more explicit here. I'm just being really quick with my writing, but what's the first term? 41? A1 plus. 41A2 plus. 41A3 plus. Blah, 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 blah. What's in every damn term? It's just this, so this, that's E just means add. If I have something that's in every term, I can take the damn thing out, yes? So this is just 41 times this, and we already established this was 20. So, could I have made this 2,000? This would have been a bigger number, but would it have been infinite? I don't give a shit when I make this convergent series actually equal to. Is this ever going to diverge? No. 41 times nothing is infinity. That doesn't make any sense. Well, the only thing that works there is infinity. Yeah? Does that make sense? If a series converges, any constant multiple of it must also converge. There's no constant that can suddenly make me become infinite. Yes? Infinite, Jeff. Okay. So that's going to play into this somehow. So here's the idea for a limit comparison. Did I put it on here? Thank the gods, I did. The limit comparison test does not always work, but when it does, it's powerful as hell. So if I'm given two series, and one little thing we'll notice about most of these is I'm assuming they're positive terms. They must be positive term series. Come back to me. Stay with me now. Okay. Here's the neat thing. If the limit as n goes to infinity of an divided by bn is L, where 0 is less than L is less than infinity. I just wrote a lot. Basically, if the limit exists and is finite. Yes? Let's think about this for a minute before I get to the conclusion. I really want this to immediately make sense. So if the limit was 2, which sequence has bigger elements? The top one, yes? In fact, if the limit is 2, eventually the top one is basically twice the bottom one. Do you guys see that? So let me put this down. There is a conclusion here. Leave some room. There's a conclusion to this theorem, yes? I don't want to get there yet because I'm weird. So if, let's say this limit is 2. So this is kind of side work here before I finish this theorem. That means that somewhere in this series, some n, yes? 1, 2, 3, 18 billion. Somewhere, an is basically 2bn. If this series converges, what does this series do? And if this series diverges, what does this series do? And what could this have been? Would it matter if it was 2 million, 20 million, 2 trillion, 2 billion, 2 quadrillion, 2 sextillion, 2 trillion to the trillionth power? Wouldn't this still, if one converges, the other one does. If one diverges, the other one does. As long as this limit is finite. The idea is so simple. I love it. If the limit of the ratio is a number, that effectively means this is L times this after some point. And then whatever one series does, the other one must also do. Now, so let me finish it up. Then both series converge, or both series diverge. So if the limit comes out to be a finite number, whatever one series does, the other series also does. So real quick, let's look at a problem we just did. You guys have, and again, just to remind you guys, if you're writing all that down furiously, it's right here, right? It's on the sheet I gave you. If the limit exists and it's finite, then either both series converge or both diverge. Blah, 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 blah. Oh, we might as well do these. Why did I start off with such a weird one? I don't know. What is your gut feeling for number one? Do you think it's going to converge or diverge? We get a few different possibilities. Huh? It's a trippy one, yeah? Okay. How do I say this? I'm going to try to give it a hint without giving too much away. Here, let's start with this one. I don't know why I started with such a trippy one. Start with this one. Can you guys see when n gets really big? What is it trying to be? Now, real quick. Limit comparison. When would limit comparison tests fail? So remind me, limit comparison means if I take the limit and I get a finite number greater than 0 or less than infinity, yes? So when could the limit comparison test fail? If I take the limit and I get 0, or I take the limit and I get infinity. If that happens, then you have to try to do direct comparison, for example. Yes? So can you guys imagine I could do direct comparison here? Yes? Because I could, can I erase it or can I replace it? Yeah, okay. And here I am making fun of this thing and I actually love it. But what's really funny about limit comparison is, if I was going to do direct comparison, what would I do first? I would say that's trying to be what again? I'm sorry, I don't know if somebody said it. What's that trying to be? 1 over n squared. Yes? That is Bn. That is Bn. That's what I'm going to compare it to. So I'm going to say this is my an, and I'm going to say Bn is 1 over n squared. Direct comparison would try to finagle an and make it look like Bn, right? And that gets a little trippy. Limit comparison just says, just divide the 2 and see what the limit is. Yeah? So. Can you guys set it up for me? The limit, n goes to infinity. An divided by Bn, yes? Which is the same thing as an times the reciprocal of Bn. You're going to get a bunch of frickin' fractions. You might as well use that fact, yes? If I want to divide this by this, I can multiply this by this guy's reciprocal, yes? That's much better, isn't it? 3n squared plus n over n to the 4th plus square root of n times n squared over 1. That's a 1 there. That's neat. I need to learn to not look at the monitor when I do this. Okay. What does that become? Heap up, heap up. 3n to the 4th plus n cubed over n to the fourth plus square root of n. And can somebody tell me very quickly what that is? You can do it. 3. The degrees are the same, yes? That is 3. So what's the result say then? Why? This is between 0 and infinity, and Bn converges. Why did Bn converge? Why did Bn converge?
Because P was.
Good. P is 2, which is greater than
1.
1. Then An converges. Blah. Okay. So again, the limit comparison test says if the result of the limit of the ratio of the two series is a finite number, greater than 0, less than infinity, the two series do the same thing. Yes? But you still don't just say converges. Since 3 was between 0 and infinity, and since my comparison series converged, why? Because it was a p series, p greater than 1. Then our series converges, yes? So you have to kind of walk through what got you to the answer. Does that make any sense? So the first step of limit comparison is the same as the first step of direct comparison. What's it trying to be? Direct comparison then says, ooh, try to make it look like that. Limit comparison just says, screw all that shit, just take the ratio and see what happens. Yeah?
Do we always use BN?
Always.
As the one that we first
Oh,
looked
it
at?
really doesn't matter. It doesn't matter if I would have turned this around. The limit would have then been 1/3. Yeah? Do you see that? It doesn't matter which one you call AN or BN. I just always call the thing I'm given AN because that's what it normally is. So the thing I'm creating is BN. Does it matter? Nope. Oh yeah, this is a little trippy too, but all right, yeah, we got to come back to this one. But what do you guys think about this guy? What do you know about natural log of n? It grows very slowly. So if I had to guess, I would say this looks like it probably acts like 1/2n. If I had to guess. Because the ln of n is not going to add enough to the bottom, almost likely, almost for sure. So try to take that limit. See what you get. So what I'm saying is, for this problem, something we could start with until somebody tells me otherwise. Oops. This is my AN. This is trying to be natural log. So my BN could be this, yes? Or it could be 1/n, doesn't matter. You'll run into a roadblock pretty quickly. So here's the nice thing. This again, if I ever have to divide two rational things, I just think of it as this times the reciprocal of that. So this just goes up top, yes? Now what happens here? What does the bottom go to? Yeah, don't tell me that the answer is 1 because this guy actually goes to infinity, yeah? Now, real quick, isn't this infinity over infinity officially?
So L'Hopital's?
We could do L'Hopital's. Let's see what happens here. So if I do L'Hopital's, here, I'll do the top. Oh boy. Keep going. What's the derivative of the bottom?
2 plus 1/n.
Ah, so now we got it, right? So this goes to 0. So this limit is 1. Does that do what it's supposed to? To have a good answer? Does the test not fail? Yes, it doesn't fail because this is greater than 0 and less than infinity. Therefore, since 1 over 2n is a divergent, what kind of series? Is it divergent? What kind of series? What kind of series? How do you know it's divergent?
Oh.
P series. Divergent P series. P equal to 1, which is not less than, sorry, not greater than 1. Yeah. Our series also diverges. So the series I pick to compare mine to, if the limit does come out to be a finite number greater than 0, less than infinity, the two do the same thing. If one that converges, the other one converges. If one diverges, the other one diverges. It's almost too nice to believe. I don't know if you guys trust me. So coming back to this first one. What time is it? Oh yeah. Coming back to this first one. Does anyone have any suggestions? All right, real quick. Do you guys think it diverges or converges? You think it converges? You think it diverges? Okay. Also, you go. I think it reverges. Yes.
Oh, could you just make it into a geometric series since they're all like in the same degree?
I cannot. No. Could I factor an nth power out of the whole thing?
I don't know.
Okay. No. Very quickly. Can you guys remind me? How would you simplify x plus 2 squared? How? Is this equal to this? Yay! That was fast. No, why is that wrong? Very wrong.
Because it's x plus 2 times x.
Yes, it's it times itself. So real quick. Okay, real quick. And I've seen evidence of this kind of thing throughout some of the homework and so forth. Powers do not play well with addition or subtraction. Why not? Because what are powers based on? So they will play well with multiplication. What is 2x, 2 times x squared? What is that? Kick-ass. Look at that. It's playing so nicely together because the operation inside is the one that it is based on, yes? If the operation inside is not the thing it's based on, it's not going to play well. It's not going to be easy. I've got to create a whole thing and then pretend like it's hard to remember and give it FOIL. Sorry, I just wish FOIL never existed. Not aluminum foil. Aluminum foil is awesome. But all you do is repeated distribution, right? It gets a turn, it gets a turn. So I cannot pull an n out because it's addition in the middle. So they can't work well together. Okay. So do we have an idea, a feeling about whether or not this thing converges or diverges? One person said it diverges. Here, real quick. Let's do this. Look at the reverse of this. Does it make sense that, how do I say this? How do I say this? If this converges, that might tell me something about this, potentially, yes? If the limit of this one is 0, the limit of that one might be infinite. This one, really quickly, would be this. 2/4 to the n plus 3/4 to the n. That's two separate geometric series. Both of them do what? They both converge, so of course the whole thing converges, yes? So it makes me feel as if this is a good chance that this is probably going to diverge. Because here, the top wasn't bigger than the bottom, that's why it converged. So here, the reverse must be true. Okay, so if I'm using limit comparison, it actually doesn't matter, but I want to start with, you guys see, does this converge or diverge? Okay. Let me see you guys. What should I compare this to then? What's kind of in there? If I ignore this, what is that? 2 to the n. If I ignore this, what's that? 4/3 to the n, yes? You guys kind of with me? Okay, so let's try this. Let's try it. You ready? And this is pushing my luck. I don't know why past Jeff put this first, because this is a little bit trippy. But past Jeff was just, he can be an asshole sometimes. I'm gonna pick Bn to be this. For 2 reasons. It's in there, yes? And it diverges. And we felt pretty confident that our original diverged, yes? Okay, let me stop for a minute. Are there gonna be a ton of problems like this in the homework? No. Could there not be anything like this at all in the homework? Yeah. But the logic I employ is kind of like related to maybe some of the harder problems. You have to kind of think the same kind of way. So I picked my Bn based on 2 things. What's in there, and what do I think that does? It diverges, and it's kind of a piece of that. So let's see what happens. Here, you guys set up the limit, yes? This is An, that's Bn. Can you set up the limit? Really pushing my luck on this one. This is trippy, by the way. This is trippy. So if you're having some trouble with it, you're fine. Huh? Oh, no. If the limit is a finite number between 0 and infinity, these 2 series do the same thing. So since the limit was between 0 and infinity, whatever this one does, this one also does. Does that make sense?
Yeah.
Okay. So let me see, let me catch up to you. Limit n goes to infinity, An, times the reciprocal of, let me do this, of Bn. Is that cool? Divided by something is multiplied by the reciprocal. What do you see that happens right away? Be very careful. There's one thing that happens right away, and there's one thing that's going to happen later. What happens right away? No question. What cancels? 4 to the n cancels. Yay! Okay. Calm down, Jeff. Why can't I just cancel the 3 to the n? That's right, because that ain't how algebra works. Okay. Do you guys remember how we did a problem? Don't write this down. How we had to do a problem like this before we learned the shortcut? Didn't I have to divide by the highest power of x? If you divide by the highest power of x, you get this stuff. And these go to 0, so then and then we develop the shortcut, yes? What is the highest thing? What's the biggest piece in here? Between the various pieces? 3 to the n. All right, so let me divide everybody by 3. Oh my God, Jeff, what is that? I think I just taught myself Arabic. Okay. I'm going to divide top and bottom by 3 to the n. 1 over, what's 2 to the n divided by 3 to the n? 2/3 to the n. And 3 to the n divided by 3 to the n is 1. What's the limit as n goes to infinity of this? You could do it. 0. Right? It's like a geometric little piece, yes. So it's going to go 2/3, some 2/3 is 4/9. It's just going to keep it doing smaller. Goes to 0. So what's this limit? 1. Now, real quick. This is perfect. Be very quiet. No, be very careful. The result of that limit, don't think, okay, it's 1, so it's not 0. No, it's 1, so it's not. No. The result itself doesn't tell me anything about convergent or divergent. The result being 1 tells me whatever one series does, the other series does. You guys kind of with me? You gotta be really careful about limit comparison. Since this is between 0 and infinity, and Bn is what kind of series? Divergent. What kind of series? Geometric. R equal to 4/3 greater than 1. Then An must also diverge, yes. So the limit comparison test, dadgummit, the result doesn't immediately mean converge, diverge. It immediately means they do the same thing. So whatever one does, the other one does. Normally students find that makes a little more sense. They do have some trouble with the floor and the ceiling things sometimes, but I have no idea which one you like better. Okay. So, if you're up for it, we can actually end class now. How's that sound? Yes. So everybody got a practice test, yes? I gave this out, didn't I? Yes. So I'll have the answer key on Tuesday, a week from Tuesday. Do not come to class next week, because probably won't even go to campus. Hopefully you have a good break. I am gonna break the hell I'm gonna break. So I will be nice and relaxed when I see you next time. And hope the same for you. All right.
So,
Oh,
we're not taking the limit of Bn.
nope.
I'm just confused on why we have to do like the limit and everything. It's just like, oh yeah, Bn is more divergent, so,
But Bn is not our question. Right?
yeah.
Bn is the series we made up. We made it up very specifically. And we know what it does, but we don't know if it necessarily means ours does. So, here, this is what I was considering doing instead of letting people out right away. What is this trying to do? B1 over n, yes? So if I try to do limit comparison with this, so I'm going to divide it by 1 over n. Is that Bn is 1 over n? Is that cool? So I'm going to multiply by n. Oh, this is not what doing what I wanted to. Wait a minute. I got to remember, because this is going to be 1. This works. Oh man. Well, now I'm kind of happy I didn't do it.
But like, how
There are series that fail the limit comparison test, and then you have to go back and do direct comparison instead.
Yeah.
Yeah.
But like with the one that we just did, how we were like referencing like, oh yeah, Bn diverged or whatever.
Sure.
So this diverged.
Yes, because the limit came out to be between 0 and infinity.
So we're taking the
Thank
limit of a variation of Bn.
We're taking the limit of a series we created based on what an was. Yes.
So the
And like I said earlier-
the small thing that we created, like the 4n over
Yes.
3n,
Yes.
isn't all of Bn. All of
No,
Bn
no,
would
it
be
is.
if we multiply that by,
No. So on that problem, an was this, yes, and bn was this. No, 4/3, yeah. So we know this diverges. That is bn.
yes.
That is. So the limit, just to really be sure you see this, is going to be this divided by bn. But I normally don't even write that step, because I know if I'm going to divide, I just have to multiply by the reciprocal, right?
Yeah.
If the result of this limit is a number between 0 and infinity, that means our series are kind of just a multiple apart. One is twice the other one is whatever. In fact, this limit came out to be, what was it again? I can't remember. This died 1,
It was 1, I think.
was it 1? Yeah, it was 1, yeah. So that means eventually n gets big enough where an and bn are like the same number.
Okay.
If the limit is 1, so watch this is kind of cool. If the limit of the ratio of two functions is 1, that means eventually f of x is basically g of x. When I get big enough x, this divided by this becomes basically 1, yes? Which means this equals this.
But if all we need to see is if Bn converges or diverges,
Yes?
why do we need to do the whole limit thing?
Because it's a guess. Bn is a guess. The limit comparison is what tells me, oh yeah, that worked. That's
Okay.
correct. That's a good guess. Bn is not an. It's built off of an. So I can't just say, well, the thing that looks like it did this. No, I have to actually show, okay, they are valid, they are connected.
So that's how you were able to say in your little explanation of why they both converged that,
Well, in this case, diverged. But
or
yeah.
yeah,
Since Bn diverged and our limit was between 0 and infinity, they both do the same thing, so the other one diverges. So limit comparison just tells me, do the two series do the same thing? Yep. What's up?
Quick question about,
Oh, there.
oh,
Let me turn this off. It's a very exciting part.